Module 3, Chapter 2.3, Stretching, Shrinking, and Reflecting Graphs. Now remember what we did in the last module. Transformations by adding or subtracting a constant to a function can cause a shift, either vertically or horizontally, in the graph. In this section, we will see how multiplying the function by a constant will affect the graph of the original function. We will refer to these changes as stretching, shrinking, and reflections. First thing is vertical stretching. If c is greater than 1, the graph of y equals c times f of x is obtained by vertically stretching the graph of y equals f of x by a factor of c. The larger the value of c, the greater the stretch. For instance, y equals 2x. What we do is we consider the graph y equals x, which was our identity function. Y equals 2x means c is 1, so that means for every y value, we're going to change it to that times 2. So 0 times 2 does not change. But for instance, if this was up 1, then for the new graph is 1 times 2 is up here. If this old point was up 2, now when we multiply that by 2, we're up 4. So what happens is this new graph is stretched, or is a lot steeper, by a factor of 2. So if we had our original graph is this black line, which I'm now going to make a white line, and then we have c times that function, whatever c is, we're going to multiply that, and that will give us the new one. It's going to be c times as high, and it's going to be c times as low, and anytime it did cross the x-axis, it's still going to cross the x-axis. Now, vertical shrinking will happen if c is between 0 and 1. So if c is between 0 and 1, the graph of c times f of x is obtained by vertically shrinking the graph of f of x by a factor of c. And the smaller the value of c, the greater the shrink. So same thing. If f of x is this original black line, which now we're going to make a white line, then if c is a fraction, it reduces all of these values by that factor. Okay? Now, vertical stretching and shrinking. Let's do a couple of examples on our calculator. Consider f of x is equal to x squared. Okay, so we're going to come up here and we're going to go to y equals x squared. And then I want you to consider 2x squared. And then I want you to consider 4x squared. And then we will consider 8x squared. Now, as these come in, if I hit graph, and I'm going to hit pause. There's the first one. I'm going to hit pause to stop it. There's plain x squared. 2x squared, we took all of these, whatever this y value was, and multiplied it by 2. 4x squared is even narrower because we took this 1 and multiplied it by 4. And then 8x squared is going to be even more narrow. So if you'll notice, as the number in front of the x squared got larger, the graph became a lot steeper. Now let's do it again. This time what I want you to do is consider 1/2 x squared. And I'm going to say second insert 1 over, so we'd have 1/4 x squared. And then we're going to insert a 1 over, and we'll have 1/8 x squared. Now watch this. There's our plain x squared. If we multiply that by 1/2, notice it's just a little bit wider. It's about half the values that it was. 1/4 x squared is even smaller, and then 1/8 is even flatter. So as the numbers in front of the x squared get smaller, the graph gets a lot wider, or we call that vertical shrinking. Okay, same thing for f of x is equal to x to the third. If we went through and changed that to x to the power of 3, we'll go ahead and do our 1/overs first. Power of 3, 1/over power of 3, and 1/over the power of 3. So now remember, this is our basic x to the third graph. So if we're doing fractions, 1/2 is going to be a little bit more wider. The y values are going to get big slower. There's our 1/4, and there is the 1/8. So notice they just keep getting wider and wider. Let's go back and do another one. X to the third, 2x to the third, 4x to the third, and 8x to the third. So there's our x to the third. Here comes the 2x to the third. Notice that got a little more narrow. 4x to the third, it's a lot steeper, and 8x to the third. So as the numbers get larger, the graph becomes steeper. Okay, now when we talk about reflecting, it's sort of like symmetry. For a function y equals f of x, the graph of y equals negative f of x is a reflection of the graph across the x-axis. Okay, if we change the sign on the y values, then it's going to be on the other side of the x-axis. For a reflection across the y-axis, we're going to change the sign on the x value. So for the function y equals f of x, the graph of y equals f of negative x is a reflection of the graph across the y-axis. Now, given the graph of y equals f of x, what would the graph of y equals negative f of x look like? Well, remember, we're changing the sign on the y values, which means if we change this y value, we still get 4, 0. If we change the y value on -1, -3, we would get -1, +3. On 2, 6, we would get 2, -6. And on 7, 6, we would get 7, -6. So in this case, this one goes up, this one goes down, and this one goes across. So that's what the reflection would look like on that one. Now on this one, we're changing the x's to negative x, which means we're going to reflect it across the y-axis. So basically what we're doing is we're taking all of the x values and changing the sign. So if this is -4, 0, we're going to come over here as 4, 0. If this is -1, 3, we're going to come over here as 1, -3. If this is 2, -6, we're going to come over here as -2, 6. If this is 7, 6, we're going to come over here as -7, 6. 1, 2, 3, 4, 5, 6, 7, 6. And then we're going to connect those. So that one's going to go up, that one's going to go up, and that one's going to go over. So we get the reflection across the y-axis. Now, to do reflections with the calculator, now we could do this manually, or we could enter it a little bit different. Okay, so for instance, if we went up here to y equals, let's clear all these out. And we went through and said if y equals x squared plus 6x plus 12. And if we wanted to graph or to get the reflection across the x-axis, remember if we wanted across the x-axis, then we're going to change the sign on the y values. So what we're going to do is we're going to come down here to y2 and say let that be the opposite of y1. Okay, and the way we find that is we go into the vars, then we slide over to y variables, and we want the function of y variables, which would be right there, so there is the negative of y1. So when we graph that, there's the x squared, and then if we shift that across the x-axis, then it shows up down here as the negative of. Now, if we wanted the reflection across the y-axis, then what we do is we come back over here and we leave our x, let's leave our x, y1 the same. And then what we're going to do is we are going to do y1 and then in parentheses negative x. And that way it will go into y1 everywhere you had an x, it will plug in negative x. So there's the first equation. And there's the second equation, which is just like it, but on the other side of the y-axis, or the y-axis. Now, let's do a big one. Describe how the graph of y equals negative 3 times x minus 4 squared plus 5 can be obtained by transforming the graph of y equals x squared. You see that little x squared sitting in here? Here's our x, here's our squared. So, the plus 5 is going to move our graph up 5. The minus 4 is going to shift our graph to the right 4 places. The 3 out front is going to do a vertical stretch by a factor of 3. The negative means we're going to reflect it across the x-axis. Okay? So let's practice. Let's write this up here. Y equals negative 3 times x minus 4 squared plus 5. So the first thing we're going to do is our horizontal shift. X minus 4 means we're going to go to the right 4 places. So we throw in our x squared. Next thing we're going to do is shift it 3 places. Vertical stretch it by 3. So if this was 1, now it's going up to 3. If this was this, then we're going to do it times 3. Every value gets multiplied by 3. The negative 3 means we're going to reflect it across the x-axis, and then the plus 5 means we're going to stretch it shift it up 5 places. Now caution, the order in which transformations are made is important. If they are made in a different order, a different equation can result. For example, the graph of 2 times the absolute value of x plus 3 is obtained first by stretching the graph of y equals the absolute value of x by a factor of 2. and then translating 3 units upward. The graph of y equals 2 times the absolute value of x plus 3 is obtained by first translating the graph horizontally 3 units and then stretching by a factor of 2. You are now ready to complete the homework for this section on MyMathLab. Once you have notes from each section and have scored at least a 70% on each homework section from this module, then you're ready to take your quiz on Module 3. Remember, you need to take your quizzes in the lab or in the classroom.